Hi everyone, welcome. It's our time. So I assume that you downloaded your R Studio and R as I instructed. Now you are going to open your R Studio, and once you first open it, it is going to have a same format as I see here. The first thing I require is that you download the file that I put on in Blackboard, and that's an R file, and just put it in a folder that you know the location of, and then just go to that folder on your computer. And my folder is under teaching, and then MBA 640 chapter 7 R work. Okay, and once you go to that folder, go and click on more and set it as working directory. And once you do that, you also see that the code for setting the directory to that folder is shown here. Now I'm going to click on this intro R file, and the file is going to open here. And the next time, if you want to see that folder, put everything in that folder, you could just copy this code and then just paste it there. So R is a data analysis software. You can do a lot of different statistical analysis using R. And what you have to do is you have to code what you are going to do, but it is not going to require a lot of work. We will just use simple codes like regression analysis and some other data mining tools. But I will provide most of the codes to you, but you just need to know how to use them on new problems. So this part that you see here is the area where you put your codes. You do not have to type them and put them there. You can directly type here under the command, the console, and that would work too. But putting your codes in an R file like this is a script file that you could retrieve them later, and you can rerun them whenever you want. Let's first start running these, and I'll explain the other parts later. And this part, you are seeing that the files that you are going to use are the plots that you are going to generate, and packages if you need to install some packages or not. Okay, and help is going to appear to show you help for different R functions. So let's just go to the second row here, and then up here you are seeing that run the cursor, and it also tells you the shortcut for this. For PC users, it's Control Enter. I think it could be Command and Enter for Mac users. So whenever you just run this, it is going to run a single row. So let me just go to this the second row here, and then just click on run. And what happened is, the meaning for this code here is saying that assign the value of 1 to a variable a. So a is equal to 1. But instead of using equal to sign, you are using less than or equal to and a dash, which is the earlier times when the R developers developed R in this format. But you don't have to do this. You don't have to put that, the less than sign and then the dash. You can directly type equal to what I'm going to do. But if you just seek for some online help, then you will see that the symbol is used, so that means it's just equal to. Now I'm going to just maybe change this and make this a equal to 2 and run this row. And if I run that, now instead of a being equal to 1, now a became equal to 2. Now I can also make a equal to 6 Control Enter, and as you are seeing here, whatever code that I run here, it also runs in the console. Now I'm going to give you a couple of very basic details about R. If you are using two equal signs together, that means is it the case? So you're checking that condition, is A equal to 5? So if I run that code here, then you are seeing that it is false. It is not equal to 5. And if you use equal to sign with an exclamation mark, then is A not equal to 5? And it says true. A is not equal to 5 because A is equal to 6. And then B is equal to 4. As you are seeing here, the variables A and B, they have the values 6 and 4. And then C, I said A times B, and I run that, and C is equal to 24. So these are basic variables. I also want to show you a couple of arrays where you can also generate arrays in R, and we will just use them maybe for regression. So what I wanted to do is, so I'm going to create names array with the values of Jen, Ken, Ben, and Pen. So if I run this, what you see is you are seeing an array with a character array with 4 values, and values are Jen, Ken, Ben, and Pen. Now I'm going to run another array, and these are hours. Let's say these are hours of studies for Jen, Ken, Ben, and Pen, and I run that one, and the values are now 2, 5, 6, and 10 for that array. And then I want to also put something else, grades, and the grades of Jen is 50, Ken is 60, and Ben is 80, and Pen is 100. Now, if I want to combine them together and make it something look like an Excel spreadsheet where you have variables in each column, like a data set that you use in Excel will have some variables, and the variable names would be on top, and you could combine them into a data frame. And the data frame is something that you would see it very similar to what Excel spreadsheet is. So I'm going to just say that data, let's just call this not data but my data, and my data is another variable, but this my data is going to become a data frame, and this is a function, and it is going to use these 3 arrays in there. So I'm going to just run this. Now I have my data, and my data now has 4 observations of 3 variables. Let's just click on this, and we are mostly going to use data sets like this. We are going to import data sets from Excel into R, and they are going to look like this. You can click on them, sort them, and you can sort based on the grades. It is going to function something similar to Excel, and we will just use this to do our analysis and maybe create some charts, do regression analysis, and do some data mining as well. So let's see if my data set, how does it look like. So I'm going to say str. Str is a function, and it stands for structure. So what is the structure of my data set? And it wasn't data, I just changed it now to my data. So I'm going to say, what is the structure of my data? I will run this, and it says that my data frame has 3 variables. Names variable is a factor. So this is a variable with category. So it's a categorical variable, and these are the 4 categories, the names of the people. And hours is a numerical value, and grades is also a numerical variable. So these are numerical variables, and this is a factor. So I want to see how the grades, so this descriptive statistics of grades in my data set. So instead of just looking at everything in my data set, I want to see my data, the grades variable under my data, and the way to represent this is my data $ grades. And if you want, at this point, you could just put some comments and say that let's say the dollar value represents the variable within the data frame. Okay, so what you do is you put the $ and then you put one of the variables within my data. So under my data there are 3 variables, and I want to choose grades, and I want to look at my summary statistics about my data grades. So if I just control enter, run that, it gives me the minimum value, the first quartile, median, mean, third quartile, and maximum value. So, and if I do this for my let's say summary of not the grades but the summary of my hours, then this is going to show me the summary of the hours variable. Now let's install a package for R to get nicer looking graphs. And what we are going to do is we will use these packages, and whenever I need to install any package, I'm going to tell you to install it. The way to install a package in R, you could just directly use this command, and then once you install a package, you have to activate the package and using the command library. So you could just use these 2 commands one after another. This is the package, name of the package that we are going to install, and the same package, after installing it, we are going to use it. So what we could do is we can go to packages, and then we can just click on install and type the package name there, ggplot2, and make sure that you are going to use the exact spelling and the lowercase. If the package name is all lowercase, you have to do that. This is case sensitive. So if I just say ggplot2 and install it, what you are seeing here is you are seeing the exact same command under there, under the console. And instead of doing that, we could just directly type the command here, the function, and then we could get the ggplot2 installed. Then let's just activate it. Now it is activated. Now we are going to try to create a couple of graphs. The first graph that we are going to create is we will use the function qplot. So the function qplot is a function for the ggplot, but you can also use a simple plot, and let's just do that, plot of hours versus grades. Okay, under data is equal to data is equal to my data. Actually, I just changed this. So using the data set my data, create a plot for hours and grades, and when I put these as X and Y, now R knows that this is going to be a scatter chart, so it is going to create a scatter chart like this. And if you want, you can zoom and you can copy this image and put it somewhere else. Let's see how it looks in qplot. And qplot is the same thing, but it is belong to this package. So under, I'm gonna make this my data again and run this. Now it looks a little bit nicer in terms of showing the hours versus grades. So more hours that you study, more grades, the higher grades that you get. Now I want to also look at the hours versus grades, but I want to show each point based on a category, so they belong to a certain category, and I have only one observation per category here, but I want to show that. I can do that using the color option under my function. So I'm going to use a color equals names. So remember that I have a variable that says names. I'm going to use it as a color. So I'm going to run that, and what I see now is data is my data. I have to do this, but for you I think I'm going to just update this and send you the updated one. So I'm going to run this, and now you see that we have the dots per person and their grade, and this is my scatter chart. This is not easy to do in Excel, but it is easier to do now here using R. Now instead of using the color attribute, I can also use the names the shape attribute, and if I use the shape instead of having a color, I could represent them as different shapes. So this is better whenever you are going to just print this in black and white and you want to differentiate them. Instead of a color, you could just use these shapes. Now what I can do is I can use the color and shape and using the same category, then I would just have it as, again I forgot to make this my data, and we are seeing the different shapes and different colors for different categories. Okay, now let's just use another data set, and R has its own data sets in there and you need to just activate them. One of the data sets is called MT cars, so it's a database of cars and their attributes, properties. So let's just activate that and let's look at the data set here. So for different cars, the mile per gallon, cylinders, HP, and some other, the gears, etc., all the different, the weight of the car, all of them are provided for 32 cars, and this is another data frame. It's a data set that we are using. Now let's look at maybe create a histogram with bins of 10 using the data set empty cars, and we have the mile per gallon histogram. So if I run that and I have my histogram here, I can decrease this or I can increase it to 20 and run it again. Now I have more details about my histogram. Now I can also create a scatter chart like I did for my small data set we created. So I'm going to just create this qplot of empty cars, and what you're seeing here is a negative correlation, the weight and the mile per gallon, and the weight goes up, mile per gallon goes down. If you want to see it the other way around, exchange this axis, you could just say that WT is the weight and MPG is the mile per gallon, and I exchange the axis. So here then we have the weights versus the mile per gallon. We can also look at this using the color of cylinders, and when I set the color, and now R thinks that the cylinders is a continuous variable, that's why it just makes the color just darkening over period. So what we could tell R is this is not a numerical variable, it is a categorical, like different categories of cylinders. So we could just say that use the cylinders but use them as factor. So if I do that, now for each cylinder there's 4, 6 and 8 cylinders, and we are seeing how they are clustering around. Okay, and we can also look at the size as an HP. Size is another attribute. We could put it in the function of qplot. And now what we are seeing is we are seeing the factors as a color, and we are also seeing the how large, the powerful the car is. And we are seeing that for more powerful cars the weights are larger, so these are like bigger circles. And we also have a little bit like a more powerful car here, but even though that we have a higher mile per gallon and the weight is smaller. So then I also wanted to just show you how to create a box plot and using the cylinders as a factor. That means for different cylinders, what is the box plot of my mile per gallon? And this is the way how you create your box plot. What you need to say is say that create a graph, but create a box plot using empty cars. Then I'm seeing here that this is the range of mile per gallon for 4-cylinder cars, and the variance is larger. For 6-cylinder cars the variance is very small, they're around 20 mile per gallon, but for 8-cylinder it is smaller than the other two, it looks like, but there may not be a significant difference between these two. There's and there's an overlap here, and there are some outliers for the 8-cylinder data. So this is just an introduction of R and introduction to some R graphs, and I will try to help you. I'll provide most of the commands, but you will have to use them for your different problems. Thanks for watching.